Hello all, my name is Jessica Tran and I go to Harmony School of Advancement. Today I did a physics PBL about mass distribution and how it affects the rotational inertia of a rolling object down an inclined plane. These objects that I used were these petri dishes that I painted and hot glued with 4 marbles of equal mass. Each of them have 4 marbles placed inside them. You can kind of see them right there, in different orientations, and the orientations are respectively, I color-coded them as shown. As you can see, these masses they're all the same mass, but they're all distributed differently. Whereas you can see here, they're all clustered together, whereas these masses are placed around the circumference, and so you have a greater radius from its axis of rotation. And we're going to see how this affects the motion of the object down an inclined plane. Before I forget, I would like to mention how this physics principle relates to the Olympic Games, which is a historically important event originating in ancient Greece as early as 700 BCE and was revived quite recently. And ever since it was revived, certain physics principles have been applied in diving competitions and ice skating competitions. For example, divers must have a firm understanding of how their rotational inertia affects their angular velocity as they twirl into the water. Okay, so when an object is at the top of an incline, it has max gravitational potential energy. And then as it rolls down, that gravitational potential energy gets converted into translational kinetic energy and rotational kinetic energy. And how we determine which of these disks go faster down the plane or reach the bottom first is whether it has more rotational kinetic energy or not. Now, rotational kinetic energy is shown right here, and the rotational kinetic energy depends on that object's rotational inertia. And as we all know, rotational inertia is an object's resistance to rotating. So the more rotational inertia means the less angular velocity because they are inversely proportional. Okay, so the general principle to remember here is that all of these petri dishes, although they have different masses, all of them have the same potential energy in the beginning because they were all let go at the same height down the inclined plane. Now what matters is what affects its motion and its speed is how much of that potential energy was converted to translational and how much of it was converted to rotational kinetic energy. In the case of the petri dish with the mass concentrated at the center, it had the smallest rotational kinetic energy because it had the smallest radius. All of them were concentrated at the center, so it rolled down faster because more of its potential energy was contributed to its linear motion, whereas this petri dish had marbles around the circumference, which means that its radius was at max radius from the center of rotation, which meant that more of its potential energy was contributed to rotating it down the plane and less of it was contributed to moving it. And therefore, it had the smallest speed, and it was sort of hard to witness the speed because it's a very negligible difference. I'll try to slow it down in the video that you will see coming up.
Yeah.